Today we're going to do algorithm analysis or complexity analysis for nested loops. So this loop starts with 1 and this one goes all the way to n, and then we have this, and then we have j goes all the way to I, and then we have j plus plus, and then we have one. Okay, I think this should be k. K goes to j, and then k plus plus, and then we have h statement here. Now we need to know how many times this statement will be executed. How do we find that out? By the way, there is a term for that in algorithm complexity calculation world, and it is called frequency count. Apparently this is a standardized term, so let's be aware of that. And well, now in order to do the complexity analysis, we first need to know what is going to be the value of n, because that would tell us how many times this loop would run. Then once we have that, we'll estimate, okay, for the first iteration of this one, how many times this would run, right? And first iteration of second one, how many times the third would run, right? And how many times the third loop would run would determine the how many times this thing would run, right? So that's how it works. So first of all, we have to come up with a value of n. In this case, I would say let's take 3 and y, because that would provide us variety. So we'll have the first iteration, the second iteration, and third iteration, and that would let us study a pattern, right? So when the value of I is equal to 1, the j, let's see, because j runs from 1 to I, and because the value of I is 1, so j would go from 1 to 1, which is up to I, right? And then what about k? Well, k also goes from 1 to the value of j. And what is the value of j? It's 1. So it would also go from 1 to 1, right? So that means in total this loop would run one time. And that also means this statement would run one time when I is equal to 1. Okay, now moving on to I is equal to, what happens there? Well, when I is equal to 2, this thing, the j, would run twice, because it would go from 1, for the first time it would iterate when 1, j is 1, right? And the second time it would iterate when j is 2. So it will go from 1 to 2. Now you see we got 2 iteration of the second loop. So for the first time, the value of the j that will pass down to this one would be 1, and the second time the value that would be passed down would be 2. So for the first time, this would the inner loop would run one time, and the second time it would run 2 times. Why? Because if you look at the nature of this loop and the condition that we have, it always runs in relation to the value that is passed down from the top, and the value that is passed down in this case would be 2. So that's why it would run 2 times. So now if this one is running 2 times here, that's why we get 2, right? So now we have to add these two. Why? Because we want to get the total number of times this statement would execute for I is equal to 2. And because there is 2 iteration of this second loop, that's why we have to add So like this statement runs as part of the first iteration of the second loop, and then it runs as the second iteration of the second loop. So that's why we have it. So moving on, when I goes to 3, right, and it would go to 3, right, when this loop ends and this loop ends, and then we're here, right. So now it is pi is equal to 3. So now j would take 3 values. Why? Because j runs up to I, and it starts from 2 and go all the way to 3, right. So that means now there are going to be 3 iteration of j, the second loop, which means for the first iteration the value of j that will be passed down to this loop would be 1, the second value that will be passed down would be 2, and the third value that would be passed down would be 3, right. So accordingly this loop for the first time would run one time, then two time, and then three time, right. And then we have to add those up. Why? Because we want to get the total number of times this statement will be executed, right. Now with this you can see a pattern emerging. So for the first time we're doing this many actions, then we get this many, and um, no, this is the correct. The 3 is not necessary over there, it's incorrect. Okay, and this is when 1 plus 2 plus 3 times this statement would run when n is equal to 3. So I wonder what would happen when I is equal to n. What would happen then? Well, in that case, we can make it a general formula like this, right. So that's what we do. Okay, now when we have that, what does that tell us? Well, this is the sum of n natural numbers, first n natural numbers. This is the sum of first three natural numbers, so we can write it as x3, we can write it as x2 and x1, sum of first natural number, and this is the sum of n natural number, and then we can write all of these as summation, so like this. Now because this is equal to sum of the I natural numbers, so we can also write it as this. Okay, having that, what can we do next? I mean, this would become, I square, and then we have I, take the constant out, because we can do that. Okay, so then we have n, and then we have I. Okay, now this tells us that this is the sum of six squares, and we know the sum of squares would be equal to n plus 1 and 2n plus 1 divided by 6, and I'm just um, adding the constant, and here the sum of the first natural numbers is going to be this. Now just to be clear, this one is sum of first n natural numbers, and this is sum of the square of n natural numbers, so there's a difference there. need to be aware of. So anyhow, now we can get rid of the constant because those don't matter, and less significant terms also don't matter. So we're just looking for dominant term, and when we multiply all of this, what are we gonna get? Well, when we multiply this one, we can get n to the power of 2, and we'll also get n, but n is less significant, so we get rid of that. And when n squared that we got it from here is multiplied with this one, we'll end up with n cube, right? So this term will give us n cube, and what with this term, this would give us n squared and n as well. But since this is the more dominant one out of this, so I'm just going to keep that. Now if we look at this, which one is more dominant? Is n cube, so that's what we keep. And that is the time complexity of this algorithm. So n to the power of 3.